This video is intended to be an explanation of how to use the open source response time tool and a brief look at the results options. But first, I need to make a couple of things clear. This is very much a tool for professionals. While in most cases, I expect it to be a pretty simple one-click type of device, the results it provides should not be taken as gospel. I've done my best to account for edge cases and for the wacky and wonderful things that monitors do, and check out the review of this monitor if you're interested, but there's no way that I have been able to fix and account for every possible thing that could happen, and it's still your responsibility to verify everything is accurate before you publish any data. To give the legalese version, I'm providing this kit and software as is and offer no warranties or guarantees of their accuracy or reliability. Now, when it comes to the kit, I'm actually providing two things in the box. Of course, the OSRTT unit itself, but also a 5-meter USB or micro USB cable that you can effectively use to connect to your system, and ideally directly to your system, and obviously still have it strapped to the monitor. The unit has an elastic strap sort of pre-attached with a tensioner on it, so if you're using it with a smaller display you can tighten it up, but generally speaking I attach it horizontally, just like this, with the USB-C or the USB cable coming out of the bottom and the button facing upwards. Although for larger displays, you might find that you want to mount it horizontally, or mount the unit horizontally with the elastic vertically to be able to fit around, so, well, whatever ends up working for you. When connecting the USB cable, of course, attach it to the device itself, but for the host side, I would generally recommend connecting it to your system directly. That gives you the most accurate input lag measurements and generally avoids issues with things like the USB voltage being out of spec that can sometimes, well, occur, especially on non-powered hubs. It is worth noting you don't have to use this exact cable though. If you already have one around, then feel free to use that. This is just one I'm providing so that it's nice and easy to get started. And finally, the button on the top is what you use to run any of the tests, both the input lag and response time measurements. It won't activate until the test program is up and selected, and currently is only used to trigger the start of the test. If you do run into any issues, generally speaking, unplugging and reconnecting the USB cable at either end will obviously reset the device and should at least allow it to work normally again. I would also recommend restarting the desktop program as well, just in case. And if you do run into any issues that require you to reset the device or the software, please do leave a bug report explaining what steps you took to trigger that, so I can at least have a hope of fixing it. When it comes to the software, the interface itself is pretty generally basic. At the top you have a number of menu options that I'll explain in a second. Below that you have the main sort of window where you have a board connection status indicator, a drop down that will be loaded with any monitors that you have connected, and the display one pre-selected. Then on the left is the response time testing section, and the right is for input lag, and also a button just below the response time section to open the results folder. If you hit the Analyze Results menu option up at the top left, that will reveal a new section which will let you import either a single raw file or import an entire folder, and that will reprocess every raw file that's in there and then average them to get an updated heat map file. The results settings options are kind of the main bulk of your settings. The output settings options include saving the final results to the pre-generated heat map sort of Excel file. You also have the option to save the raw data to an Excel file with a pre-made sort of graph view template and a manual results calculator, although I should mention that that option significantly slows down the test and can also make it somewhat unstable, at least at the moment. So generally speaking, I would recommend manually copying your data into the result or the graph view template rather than using that, but the option's there if you want to try. You also get a verbose output option to include or load more data in the individual full CSV files. You can also save the calculated gamma table, save the sort of smoothed raw data to make it easier to manually verify already very noisy data, and also the option to save raw input lag data for manual verification. By default, the recommended settings option is set for the response time measurements. I kind of outlined what those settings are and why they're there in the last video on the tool that I'll leave in the cards above for you. And I'm still planning on making a full video explaining all of the different options and things very soon, but if you would rather use your own collection of settings, you can check the advanced settings option, which will enable the menus for both the response time and overshoot settings. Under the response time settings, you can pick from effectively 6 different options, either using a fixed RGB5 or RGB10 offset, or a 3 or 10% tolerance instead. Plus you have the option to have either of those percentages based on the light level, or what is arguably more accurate, which is the RGB value. The 10% non-gamma corrected method is the sort of traditional or very traditional one. Simon from TFT Central uses a fixed RGB10 offset, and Tim from Hardware Unboxed uses a gamma corrected 3% tolerance. As for overshoots, this too can be gamma corrected, measuring the RGB value difference rather than the raw light level. You can also report it as a percentage, either based on the final light level or RGB value, or you can use it based on the sort of transition range. So for example, a transition that goes from RGB 102 to RGB 153, well, that's a range of 51 RGB values. So if the panel were to overshoot to say RGB 170, that would be 17 RGB values higher and would therefore be 17 divided by 51, all that times by 100, versus the end light level alone, which would be 17 divided by 153, all of that times 100. Moving over a tab to the program settings, you'll find the About Program option, which displays what software version you're running, and if the board is actually connected, what firmware version the board is running as well. You can also report a bug from here, set the program to minimize to the system tray instead of staying on the taskbar, suppress any error boxes that might pop up, and ignore any mid-run errors that would normally cancel the test. The latter is enabled by default, as I personally value getting a copy of the data to understand what went wrong, but if you would rather have it stop mid-test so that you can, fix whatever's up and then go back to it, you can disable that if you like. You do also have some debugging options like the debug mode and the option to save some data on the USB power stability, which is actually something I will probably ask for when troubleshooting, but generally speaking, you shouldn't need to be in here, and actually leaving the debug mode on can also cause a fair bit of instability. When it comes to the response time settings, you have 3 options. The frame rate limit is what FPS cap you want the test program, a UE4 game or project, to run at. I've set up as many options as I can for now, although I'm sure this can be improved in the future or altered later, but for now the default is 360 FPS, although the maximum is 1000, and not many systems I've tested on have been able to hit, up to that 1000, but it also goes all the way down to 60 FPS and a number of common monitor refresh rates in between. You might want to set this to lower than the monitor's refresh rate to test adaptive sync, as just changing the refresh rate isn't exactly the same. The number of cycles is how many times the test will run before averaging everything together. The default is 5, although the current maximum is set to 10, although I've made some changes that in theory should mean you can run this as many times as you reasonably like, but I'm yet to change that, but hey, by the time you use this, that might be a higher cap if you fancy.
The minimum is 1, although I can't recommend anything less than 3 for even remotely accurate measurements. The test only takes around a minute or so you aren't exactly adding hours to your testing to run it a couple more times and get much more accurate data. Finally, you have the capture time setting. This is how long the sensor captures the data for. By default, it's set to 50 milliseconds, but if you have a slower display like a TV or something with both a slow panel or incredibly long input lag, you have the option to increase that up to 250 milliseconds in 50 millisecond increments. The longer you set, the more data it saves, rather obviously, and the longer it can take to process, so it's kind of up to you what you need for any given display and your preferences. All of those settings, in fact all of the ones that I've described already, are all saved so that when you close the program and relaunch, they'll still be there for you and be reset or reloaded every time you load in the program and connect the board. They should also persist through updates as well. So again, in theory, you should be able to set your testing setup and it will stay as is. To actually test response times, well, you'll need to pick your settings, select which display you're going to be testing on, and attach the device to the monitor so that its base is nice and flush with the display, ideally with sort of no gap, especially around where the sensor is. That may mean that you need to tilt the display backwards so that it sits nice and flush. You'll also want to make sure that any backlight strobing modes are turned off. Often called something like motion blur reduction, things like ULMB, ELMB, MBR, Gigabyte's aim stabilizer. You'll also want to make sure that the display is warmed up. It should have been on for at least around 30 minutes before testing, and ideally have been somewhat active during that time as well. Once that's all sorted, you can hit the Start Response Time Testing button, and that will launch the brightness calibration window, where you should put that under the sensor. There's a little marker on the front to show you where the sensor is on the device, and then you want to adjust your monitor's brightness until it reads perfect. The raw result we're looking for is somewhere between 61,500 and 64,000, and once it's in between that, then you can hit the continue button, which will become enabled, and you can start testing. Now, hitting that button will launch the test program, the UE4 project, and that should launch on the selected display. Once you have it up and open, you can then press the button on the top of the device and it should flash the screen to white to do its fine-tuning calibration. It will then cycle through the 6 test RGB values to build the gamma table, and then will cycle through the full test pattern for as many times as you set in the cycles counter. When it's done, it should automatically close the UE4 project and launch an Explorer window that has that runs results folder open. The final processed file is the XL or .xlsx file that includes the monitor's name, refresh rate, and connection, so it's nice and easy for you to know what that test run was testing with. You'll also find the raw CSV files. Those are the ones that include all of the raw data from each run, including the gamma test or the gamma data at the top of each file, and the full CSV files, which are the process output for each run individually. Opening the final Excel file should bring you to the recommended presentation page, which includes 3 heat maps, stat tables for each of those, and also a couple of extra little stats as well. On the left, the table on the left is the perceived response time, as in the complete start to finish time with the sort of tolerance level subtracted. In the middle is overshoots, and on the right is what I'm calling the visual response rating, which scores how quickly the panel can get to its sort of desired color, and also how long it then takes to come to rest there. You also get an average input lag figure and an OSRTT score, which is, if I'm being honest, a blatant copy of Arting's rating system, even using the same weights as them as well.
If you want to use a more sort of traditional, say the initial response time figure, then you can hit the second tab or sheet, the view heat maps here sheets, or you can also just see all of the data itself on the first sheet, the paste data here sheet. Finally, I just want to mention that you can actually customize these templates if you fancy. You just need to make your changes to the results template.xlsx file in the sort of roots of the results folder. Just make sure that the first sheet is still the data sheet, don't move that one around, and that the refresh rate figure on the second sheet remains on L4, as both of those things are currently hard-coded into the program and will be overwritten when it saves a new file. Also, you can use the GraphView templates to effectively view your raw data individually. Just open up one of the raw files, press Ctrl A and then Ctrl C, and then open the GraphView template, enable the macros, and delete any of the data that's in the paste data here sheets. Paste your new data in and then hit the second sheet to look at the graphs. You can use the drop down to select the graph that you want, and you can then calculate the response time by manually entering where the start position and end position is in the green boxes on the left, and it will calculate things like the, well, response time, but also things like over and undershoot as well. When it comes to the input lag testing, well, you currently have two settings: how many clicks and how long between them. The default is 20 clicks with 0.3 seconds between them. You just need to hit start input lag testing to launch the test program. Currently, I would recommend pressing Q a couple of times just to make sure that the game is registering key presses correctly. It is something that I'm working on, but since I haven't yet fixed that problem, I should mention it here. And then you can just hit the button on the top of the device and it should flash the screen for as many times as you have told it to, and for as long sort of time in between them as you've told it to as well. Once it's done, it will close the game and process that data, and again open an Explorer window to that sort of results folder, where you should see both a raw file and a processed file. The process file contains the results for each shot, where it lists things like the time taken for the click to be registered by the USB controller, also the time between then and the display reacting at all, and those figures sort of combine to give you the total click to photon latency. It also includes an average, minimum, and maximum at the bottom of each of those values. In future, I would like to include things like the processing time that your system takes, but I'm not quite there yet. So that's kind of it for now. I want to add a load more stuff, things like a live view so that you can see actually what's happening just as it goes. Also a load more stuff just on top of that, so do stay tuned. If you have any questions, please do leave them below or wherever else, and I'll do my best to get back to you. And if you do find a bug, please do submit a bug report on GitHub with plenty of data, your CSVs or Excel sheets, your some pictures or screenshots and descriptions. And again, I'll do my best to get it sort of resolved where possible. Just again, a final clarification that I am one idiot in his literal bedroom making videos and designing and writing everything for this. So this is as best as I can make it, but it is not a professional tool. It's not an off-the-shelf device that, there's no big support team, that kind of thing. It is literally just me. I have, obviously all of the tech videos and actually car videos to make as well. And if I'm being honest, I struggle quite a lot with both mental and physical health problems on a literal daily basis. So my apologies if things are delayed, in especially things like getting things fixed. But yeah, that's kind of that really. Of course, if you're watching this on YouTube and you're not already subscribed, please do hit that subscribe button and turn on the bell notification icon. There's plenty of more videos on the end cards, including 2 other videos about the response time tool that you can check out. I'll leave them in the cards and on the end cards as well.
And yeah, if you want to support the project and you don't fancy picking one of these up, then feel free to do so with the links in the description. There's direct ways like the YouTube join button or Patreon, or direct donations if you fancy, or you can support using things like the merch or hoodies or t-shirts like this one, or a load of other cool designs I made myself, or even just the affiliate links to places like Amazon or Overclockers UK. Feel free to use those. If you do want to pick one up, I'm still just taking sort of pre-orders and orders via email essentially, or if you have me on Twitter, feel free to DM me. And yeah, that's kind of that really. Hope you enjoyed the video. Thanks for watching. We'll see you on the next one.